All right, hello, math fans. All right, this is day 2 of radicals, and basically what we're going to do is we're going to do multiplication and basically squaring radicals. Okay, so let's actually start out with squaring some radicals. I want you guys to understand that squaring, if I said x squared, do you agree that that's the opposite of taking the square root of a number? Okay, so in other words, if I said 3 squared is 9. So what's the square root of 9? It's 3. All right? So basically this is the deal. If I have a number under the square root, let's just say the square root of 3, and I square it, what squaring does is it actually just cancels out a radical. That's kind of what it does. Okay, square root of 3 squared, don't you agree it's like saying the square root of 3 times the square root of 3? Okay, which we are going to talk about today. It's multiplication. That's the same thing as the square root of 9, right? And the square root of 9 is 3. So don't do a lot of work when you're doing this. If I said the square root of 19 squared, don't do 19 times 19 and multiply that together and go, let's see, how can I simplify it? It's a really easy problem. The square root of 19 squared is just 19. Okay, it's really pretty easy. So the square root of 123 squared is 123. Okay? Don't make it difficult. Square root of 1869 squared is 1869. Really, really easy. Okay, so let's add just a little more to it. If I said 2 times the square root of 13 squared. Now this is the deal. You're squaring both things. But this does not have a radical. So you're saying, what's 2 squared? Well, isn't that 4? What's the square root of 13 squared? Square root of 13 squared. Isn't that 13? So really you multiply these guys together. After you square the 2, which is 4, and square the square root of 13, which is 13, 4 times 13 is 52. Okay, so let's try a few more here. 3 square root of 7 squared. Okay, so again, it's 3 squared, which is 9, and the square root of 7 squared, which is just 7. So 9 times 7 is 63. All right, so again, you're squaring both terms, but one of them is just like on the outside of the radical. It's like back in the old days saying, well, hey, what's 3 squared? Oh, it's 9. Okay, and then what I just taught you now, if you square a square root, the square root just goes away. Okay, it's pretty simple. So let's do a couple more here. 3 square root of 6 squared. Well, it's 3 squared times radical 6 squared, or 6. So 3 squared is 9 times 6 is 54. Okay, it's not too bad. 2 square root of 7 squared. 2 squared, 4. Root 7 squared, 7. The answer is 28. Okay, let's try another one here. 2 square root of 2 squared. Well, it's 2 squared, which is 4, times root 2 squared, so that part is just 2. So it's 4 times 2, which is 8. Okay? That's squaring a square root. It's pretty mellow. Okay, so let's actually do, the main part of this now is multiplication. So the deal is, you multiply, let me just start out with an example. 2 square root of 3 times 3 square root of 5. So what you do is you multiply the numbers on the outside of the radical together. So you're going to have 2 times 3. And then you multiply and put a big square root there, and you multiply these together. So 3 times 5. So you get 6 square root of 15. All right, so that's really not too bad. Okay, but this, so if I put it like a generic thing, a square root of b times c square root of d. Okay, you basically have a times c on the outside of the radical, and then on the inside of the radical, it's b times d. So it's ac b times b radical bd. Okay. All right, so that's pretty straightforward, right? So whatever's on the outside, multiply together. Whatever's on the inside, that gets multiplied together. And then, of course, you simplify it. Okay, so 2 square root of 7 times 3 square root of 6. 2 times 3, 6. Root 7 times root 6 is root 42. And that's the answer to that problem. Right? It's relatively easy schmeezy. Okay, well, let's actually just add a little bit to it now. What happens if I give you a problem like this? Square root of 7 times the square root of 21. Now, what you need to realize is that I could multiply 7 times 21 together, but remember when we first talked about square roots, we said if you have a pair of numbers, that's the same thing as a perfect square. So why multiply 7 times 21 when you already know that 21 can be broken up to 7 times 3? Okay, which means I now have a pair of 7s, so 7 comes outside, and that's my answer. Okay, so if you can see a perfect square, if you can see something that you can pull out of there before you even multiply it, you're kind of better off. All right, so another example could be square root of 10 times the square root of 15. I mean, you know that they both have a 5. So why not just write it as one big square root, and 10 is 5 times 2, 15 is 5 times 3, and you have a square, you pull the 5 out, and remember, again, 5, a pair of 5 is the same thing as saying the square root of 25, which is just 5. So a mistake that people sometimes do is they pull out a 25. You're taking a 25 out of the radical, but it turns into a 5 because the square root of 25 is 5. Okay, so you're going to have 5 on the outside, and then what's left over? 2 times 3, which is 6, and that's your answer, 5 root 6. Okay? How about 4 root 3 times 2 root 12? Okay, well, kind of the same idea, right? I know 3 can come out of the 12. So here, 4 times 2 is 8. I got to do that right away. And I have a 3. A 12 is a 3 and a 4. So I pull a 3 out. Now, I have it kind of two different ways here. I have a I have a pair of numbers, which is a perfect square, but I also have a perfect square. Well, that means both of them come out. So you guys need to remember, like 3 times 3, that's the same thing as saying the square root of 9. So if it's a pair of numbers or a perfect square, it's the same thing. So I pull the 3 out, and I pull the 4 out. Now the square root of 4 is 2. And then there's an 8. And since there's nothing left in here, I pulled everything out. There's no radical at the end. Okay? There's no radical because it's all out. So 3 times 2 is 6. 6 times 8 is 48. That's my answer. All right, not too bad. Square root of 3 times square root of 7. Okay, well, that's just 3 times 7. You can't do anything with it, so you're literally going to multiply these two together, and you get the square root of 21. Okay? Square root of 18 times square root of 18. Remember what I told you? If it's the same thing as saying square root of 18 squared. If it's the same number, again, I could multiply that together, but why do that? The square root of 18 times square root of 18 is, here I can write it this way first, just to show you. That's just 18. It's a pair of numbers. Okay, so square root of 825 times the square root of 825 is 825. The square root of 825 squared is 825. Okay, so it's kind of the same idea. Because you remember, guys, x squared, I can write that as x times x. That's exactly what I have here. That's x squared, or 825 squared. That's x times x, or 825, root 825 times root 825. Okay, that's not too bad. What else can we do? How about the square root of 8 times the square root of 4? Well, a couple things I can do. One is, it depends on how you want to simplify it. Isn't the square root of 4 just 2? So can I just write it as 2 root 8? But remember what I told you back in the day. If you see an 8 in your final answer, you're not done with the problem. Okay, you can pull out another 4. So it's really 2, and then you have 2 times 4, right? And the square root of 4 is 2. So that comes out, and I have 2 times 2 is 4 on the outside, and a 2 left over. Okay, so it's 4 root 2. That is not too bad. All right. What about this one? 3 square root of 12 times 4 square root of 18. Okay, well, I could multiply 12 and 18 together. Well, first of all, 3 times 4 is 12. And 12, I could say, yeah, there's a 4 in there too, but think of a perfect square, or think of a number that both goes into 12 and 18. Well, doesn't 6 go into both 12 and 18? So can I say 6 times 2 and 18 is 6 times 3? And then I can pull out a pair of 6s, and so it's 6 times 12, and I have this left over, 2 and 3, 6. So 6 times 12 is 72, with a root 6 left over. Okay, that's not too bad. A couple more here. What if I said 1/2 times the square root of 5 squared? Well, guys, don't make 1/2 squared too difficult. 1/2 squared, isn't that the same thing as doing 1 squared over 2 squared? Aren't you squaring the top and the bottom? So isn't that just 1/4? Or look at it this way, 1/2 times 1/2. Isn't that the same thing as 1/2 squared? What's 1/2 times 1/2? Well, you multiply top. 1 times 1 is 1. 2 times 2 is 4. So it's 1/4. Okay, so going back to this problem, it's 1/2 squared and root 5 squared. So 1/2 squared is 1/4, which we've already done. Root 5 squared is just 5, or 5 over 1. So if I multiply straight across, isn't that the same thing as 5/4? All right. What about 2/3 square root of 18 squared? Okay, no big deal. It's 2/3 squared and square root of 18 squared. 2/3 squared is 4/9, right? Square the top and square the bottom. And 18 squared, root 18 squared is 18. That's easy. Then I can multiply, and that's a 1 and a 2. So my answer is 8. Okay. One more here. What about the square root of 6 times the square root of 3 times the square root of 18? Well, again, there's a lot of ways to simplify this, but look at it this way, guys. Isn't 6 times 3 18? So can I just say 6 times 3 is 18 and put that 18 here times 18? And what is the square root of 18 times 18? Isn't it just 18? And that's my final answer. So you have to kind of look to see what you can do here to simplify things ahead of time. Okay? That's it, math fans. Hope you guys learned something about multiplying and squaring radicals. Have a good day. Goodbye.